Okay, so we've created confidence intervals before with just a single sample, and now we have two samples. And so what we're really creating a confidence interval for isn't the population mean of one or of the other, it's of how far apart they are, how much more or better or something one is than the other one. So that's what our confidence interval is really creating here. Um, it's kind of a beast of a formula. There it is, right there. Do keep in mind that you can really just think of it as here on the left side and just doing a plus or minus sign. But let's take a look at this. So we're going to have um, the difference of the two sample means is really our best guess at the difference of the two population means. Just like our sample mean was our best guess at population mean, our sample proportion was our best guess at population proportion. The difference of the sample means is our best guess at difference of the population means. So what do we have here? Our sample mean 1780. First one. We'll just keep them in order, keep the x1s paired together and all the 1s paired together. And then 1820 is the second one. And that's going to be our point estimate, our best guess, plus or minus, and then we have our critical value. So here we have a 90% confidence interval. That means we're going to take the z of our alpha level is the opposite of that. Our alpha level is 10%, and divided by 2 would give z 0.05. Again, alpha is always the opposite of your level of confidence because it's kind of like the level of error. And then we have this pooled standard error here. So our first standard deviation is 480 squared over that first sample size is 220. And then we have 380 squared over, and the second sample size is oh, sorry, I'm sorry, read that wrong. This is 275, and this one's 220. Okay, so that gives us all we need now to type things up in our calculator. When we use the minus sign here, that will give us our lower limit, and when we use the plus sign here, that'll give us our upper. So what I'd suggest is let's calculate these parts separately. So this part here and this part here separately, and then we can add and subtract as needed here. One number we don't have yet is that z.05, and this is something we can get in our calculator. That's 1.6448. All right, I'm going to pause this while I set things up. Okay, so I've got everything set up, and this critical value, like we found on the calculator, is 1.645. All right, let's go ahead and calculate this here. So we're going to start with our 1780 minus 1820. Let's just go ahead and do the minus side of things here. 1.645 times square root of 480 squared. It's going to get divided by 275 plus 380 squared. That's going to get divided by 220. Okay, And I'm going to copy this just because I'm going to reuse this in just a second. There we go. And we'll go ahead and enter. So that's our lower limit. Is it always negative? No, not necessarily. That just happens to be the case here. All right, and then clear that out. And the only thing we need to change for the upper limit is we need a plus sign there. And make sure that we don't have a negative sign. All right, and this should give us 0.236. So what is this saying? Let's take a second here just to think about what this is telling us. So we're looking at prescription allergy relief and non-prescription allergy relief, and we're looking for the difference in the two, difference between the two. So this tells us that we can be pretty sure that these individuals will spend somewhere between $1 less on the prescription and 23 cents more on the prescription. Somewhere between those two is how much more they're spending on prescription. So it's more likely they're probably spending a little bit less since more of that confidence interval is in the negative. But we don't really even have good evidence that there's a difference between the two because 0 is in between these two, meaning that it's very possible there's no difference between the amount spent on prescription allergy relief and non-prescription allergy relief.